Okay, hello there, and welcome. This is Stefan Koch, and today we are going to take another look into the CTFE engine and a few of the problems that present themselves when doing this stuff. First off, let me make sure that everything is working so far. Okay, we rebuilt the compiler, there was nothing to rebuild. So test ctfe.d and dash bcctv. And we hope that everything runs through, and that we see all this calling to expressions stuff here means that everything did compile the way it probably should. Now, I think we have a test disabled here. Oh no, we actually don't. Oh yeah, we have this test disabled, which we can now enable again. I'm pretty sure. Oh yeah, and we have to, of course, remove the comment here. It seemed to have worked. We can enable the payload messages to see if something doesn't work. Oh, the payload messages are already enabled, so we would see as soon as something doesn't work. Okay, that's good. Let's test some more. I don't know if this struct definition seems to work. Test string equals. This has to work because we already tested it in the BC tests, but still seems to work. Oh no, it doesn't. We should have seen it to expression call here. Well, yeah, that would do it. Compiling an empty file will not give us anything. Anyway, this was already in the test, so it isn't too bad. Nullcat. Comma expression should also work the way they should work. Oh! CTFE died on argument processing. That's not good. Ah yes, it's because of this. Because we do the comparison here. We can't really do it that way. We have to take a little trick here. We gotta assign it to a static variable. And this is the fn2 result, and then we can static assert that the fn2 result equals that. This is because of problems with the how I hooked the newCTFE in. and now it's false. So what is fn2 result? Is 412. 412, so same exact thing. But for some reason we aren't getting that. So the result is definitely correct, but the static assert doesn't work. Well, whatever, we're going to fix this one day, so let's leave it the way it was. The reason why this doesn't work is pretty intricate, and therefore I don't want to get into it right now. So the default initialization seems to work, which is great. Basically everything works the way it should. And yeah, let's see what we have to work on. For now, I think there was something that didn't work quite the way one would expect. And I think it has to do with slice descriptors. I think the check for null, was it that? We should only do null if either the thing itself is null or the base is null. Yes. So that should be that. Good. So let's go through this. Or not, maybe not. Shall we just look at generated IR? Maybe we do that, and I'm going to show you where the problem is. with the test case, so we cannot compare the array. You will see that the first function that is generated here is the array equals comparison function. And it supposedly works correctly. Although inefficient when compared to memcompare. But well, what can I do? And you can see here, it has a call. Right, this call to function 2 here. Which happens outside of the function itself. Because it is the parameter to this one. What we have to do here is to wrap that thing. And maybe we try doing that. Because this is a parameter to this function actually. What is getting generated there, but you can't actually see that, can you? So basically we would generate temporary, do the call into the temporary, then we generate the array we compare against, and call this function. This would be the first thing we do. Now, to be able to do this, we gotta go in the interpreter. This is a CGD file, which gives you what the compiler spits out. You can hear a little bit of type info there, because it's getting created. This is an inline function. Blah blah blah. Doesn't really matter. Anyway, can we go? Does this thing do static start? Static something. Doesn't look like it. No, it doesn't look like it is actually properly done in here. But then again, I have no idea how this static assert expressions get lowered. Maybe it's a assert statement or something. Maybe. Yeah, probably I have to check this. Or maybe it gets lowered even before. Let's activate logging here. Create this anew. And then we should see which statement is triggering the static assert. So there's an array literal expression which takes a compound statement. So we have a cast exp, call exp, give a string exp, yeah, it doesn't seem like we have a static assert at all. This like lowers to a call exp. And if any of the parameters are calls, we have to resolve those calls specially, like we have to generate the calls first. We have to create a wrapper around the function that creates the thing. Let me try to put this into IR, so the IR would look like we're with gen, and then we have like whoops begin function 0 wrapper. That's the wrapper, and it would do like gen temporary I30 type, and this would be TMP P1. Alright, there we go. This happens 2 times. And then we would do like call, yeah, I guess auto red v equals gen temporary I32 type. Alright, this would like call. We want to create temporary P1. Is the this would be like the function number of fn, right, which would probably be 2. And then that would be that. And this would call the function like so. Then we had like call the real function, which was red v, which would be the return value, and it would do like yeah, first the function number, which would be 3 then, and then we had temporary P1, temporary P2, and temporary P2 would probably just be, I don't know, some heap address. Whether erase that, maybe like it would be at 8 or something. Then we call this, right, and then we return. Return value. Like, this would be how such a wrapper would look. And, oops, there we go. Again, this is to make this work, because this call here, this one, it cannot stand alone, right? It cannot stand alone. We have to make this thing here which is the function we actually want to call, has to be generated after, like we would do this. Then we say here end function. There we go. The initialize has to be done here, by the way, and we can't begin function one here. Function. Yeah. The function we want to call has to be begin function 2, because there's a function. Yeah, to work the way we wrote it here, this has to be function 2. And then we copy like the function that generates the thing here. We copy this. In. Whoops, there we go, and IR. And we gotta do begin function. Oh, we already do that. Yeah, so we gen the parameter, begin the function, end the function. Do then that. And I don't know why this returns a constant 32. It's this like the array address was statically allocated for it. I don't know. Those two shouldn't be at static offsets. I have actually no idea what's going on here. Maybe I just stopped the recording and debug this offline.